Hello and welcome to Algorithm Integrity Matters. Insights for financial services leaders who want to enhance fairness and accuracy in their use of data, algorithms, and AI. I'm your host, Yusuf Mullah. This article was published in February 2025. It's titled Algorithmic System Integrity Testing. There's no specific or particular point of view expressed in this article. It is just one of those really important things and is a core basic step that we all need to take. And so it tries to summarize some of the key things that need to be considered. So here we go. In reviewing algorithmic systems for integrity, we often consider how the systems are tested and what the quality assurance process is. Testing and quality assurance go hand in hand, with testing generally considered a subset of overall QA. Testing is a core component of change control. It helps ensure that algorithms function as intended. Why testing matters? If you're reading this, or if you're listening to this, you probably already know why you need to test. In brief, testing helps identify errors before systems are put into production, saves time and resources, so fixing issues in live systems is often costlier and more complex, increases confidence in system flows and outputs, and is needed to meet regulatory obligations. This could either be explicit, so for example, CPS 234 in Australia is explicit about testing, or implicit. Examples of those include GDPR, HIPAA, and many others. Testing stages. Before we explore the key testing stages, there are three important points to note. Some testing may be manual, others could be automated. Continuous testing may be necessary, especially for AI systems. This differs from traditional systems where testing may only be needed for new applications or changes. And this is because the models change without changes to code. So for example, new data inputs result in model drift, etc. And the third important point to note, if you're buying software rather than building it, the earlier steps will be performed by the vendor. So check how this is done, check that this is done, and how this is done. UAT, so user acceptance testing, at a minimum, will fall within your team. So here are the stages. This is not a comprehensive list, but it covers most core stages. Unit testing or developer self-checks. This is where developers perform initial code or flow reviews, tests on individual components or functions of the algorithmic system. This helps catch basic errors early in the development process. Then we have peer review. This is where colleagues review the code and test results, providing a fresh perspective and potentially finding issues the developer might have missed. The third stage, technical review. A more experienced team member evaluates technical aspects, ensuring it meets architectural standards and performance requirements. This may also involve other teams to conduct non-functional testing, so for example, certain security-related testing if it's not covered elsewhere. The fourth stage, functional testing. A non-technical team member ensures the system meets the intended functional requirements. And then finally, business testing, also known as user acceptance testing or UAT. So this is where end users or business stakeholders test the algorithm in a real-world context. This is to ensure that it meets their requirements and functions as expected. And this, ideally, uses real data across a variety of scenarios. Let's talk about testing across some of the key integrity areas. So effective testing should address multiple aspects of algorithm integrity, and examples of those or examples of the core aspects include accuracy, fairness, security, privacy, and performance. With accuracy, we want to verify that the algorithmic system produces correct, that's complete and valid and accurate outputs or results. So for example, we test the system using known inputs and expected outputs across various scenarios. When we're testing for fairness, we're evaluating the system for bias against protected attributes, looking for unintended discriminatory outcomes. For example, if the system now uses free text fields beyond structured data, protected attributes may be inferred. Another aspect is security. So this is where we assess vulnerabilities, making sure that existing controls are not inadvertently bypassed. For example, we check that security controls for authentication still work especially if there are workarounds in place. Privacy, we check that confidentiality is maintained and that sensitive data is protected. So for example, we verify that the algorithm doesn't reveal sensitive data through its outputs. And then performance, here we measure efficiency and scalability. For example, simulate high volume scenarios to ensure the algorithm works under peak loads. So all in, this is a basic but important set of steps towards algorithm integrity. A testing strategy that covers various aspects can significantly enhance algorithm integrity, ensuring the systems are not only technically sound, but also fair, secure, and aligned with business objectives. That's the end of the article. Thanks for listening.